if there's any questions you guys have, you want to discuss anything, please feel free to either talk to me now. I have no, ask me questions right now, or if you feel shy, I'm on LinkedIn. Send me a message. I'll be very happy to talk with you. And that's another important aspect I forgot. In LinkedIn, especially if you're trying to go into industry R&D, LinkedIn is a very important tool. Knowing people, getting a big network, talking to people directly. And LinkedIn is one of those platforms that allows you to directly talk with lab managers, with directors, with VPs, whatever, right? So use those tools that are available to you, and use that tool to connect with me, to talk with me. If you have any questions, feel free to ask. Thank you. So yeah, I'll give it over to Soumya and Praveen to sort of take care of the questions aspect.
Hello.
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 I am Praveen Dhananjay. So I like to, my interest is robotic and computer vision. What are the companies, how to join them?
Very good question, right? Robotics and computer vision. So robotics and computer vision, everybody needs computer vision people these days. Let me put it that way. But with that said, everybody does computer vision. So it's very difficult. So your research area depends on what application you do, right? So you can get into Samsung research, the division I'm working in. Mine is particularly in imaging, so that's not so much in the computer vision area, but we have sister labs which are in computer vision. So you use computer vision for autonomous driving, you use computer vision for image signal processing pipeline. You have all kinds of different areas that computer vision can be used in. You can apply to, just to give you a few names, of course, that in Google there are research labs. In Google, there are software engineering positions that also let you work on computer vision, right, in the deep learning aspects. And if you go to robotics, you have your Boston Dynamics, you have, I'm not an expert in robotics, so, I am not a know-it-all in that area, right? But in computer vision, you could go to Google, you could go to Amazon, you could go to Samsung, you could go to any name you could come up with. Any company nowadays does computer vision. I mean, even go to your General Electrics, the people who make your CT scanners, right? They need computer vision people now, because now the algorithms, some of them work on deep learning, some of them don't, but they need deep learning people. They need people who know how to, and so one of the things is, if you get trained in computer vision and you are doing analytics extraction, that means you get an understanding of how deep learning works. And knowing deep learning as a tool is very important for different fields as well, right? It doesn't necessarily have to go back into analytics extraction. It can also go back to different problems solved with the same theory. And that's another important part, right? When you do a PhD in a certain aspect, doesn't mean you're a one-trick pony. What I mean by that is you're not limited to doing just the one thing, right? Your training allows you to do different things. For example, getting myself as an example, I did computational imaging, right? My first job was in computer vision, and I was working with radar. Actually, I was working with radar signal processing for computer vision applications, right? Computer vision, by the way, does not necessarily mean it has to be camera images. It could be anything. But the important thing is, what did I use there? I used particle filters. I used Kalman filters, extended Kalman filters. I used statistics, right? Particularly this theory called Dempsey-Schaeffer theory. What's the important thing there? It's the theory I learned in graduate school. I learned particle filter in my video processing class. What did I use it for? Radar signal processing, right? But the important thing is, the mathematics, the application doesn't matter. The application you have to learn, but the harder part is understanding the underlying theories you could use for modeling a problem. So if you know those underlying problems, you have a lot of opportunities. So since you're you have a good understanding about robotics and computer vision, you have all these different places you could apply to, right? And I would encourage you, talk to people in the industry. If you want to talk to me, if if your qualifications are matched to the people I know, the place I work, I'll be happy to guide you to the next step. And that's the other thing, right? Just like me, I'm not doing any advertisement for any company here, by the way. The idea is, talk to people like myself who are in the industry, who do the jobs that you want to do, or the postdocs that you want to do. Talk to them directly. Ask them, hey, this is my resume. Do you think I have a shot at working at where you work? Some people are nice. They'll respond to you and say yes. Others will ignore you. Who cares if they do, right? People will ignore you. That's an important part of life, right? Some people will pay attention to you, some people will ignore you, but there's no harm in asking. The only mistake you could do is not asking. So please ask the questions. If you don't get the answers, that's fine, but the important thing is be polite, be professional, right? Be very professional when you talk to people, and the more professional you are when you're talking to people, the more they'll respond to you, the more they'll like to help you, right? It's not always about having the best resume, it's also about being a very good people person. So my advice to you is talk to some folks, and ask them for referrals. Ask them, hey, do you know a guy in this area, can you help me? Or if you know a person, let's say for example, who's a connection of mine on LinkedIn, be like, hey, introduce yourself to that person and tell them, hi, I know Dilshan, and can you help me with this aspect, right? So those are all very, very important things to understand. So I hope that answered your question. If not, please kindly follow up.
Thank you, sir.
Of course.
If any of the participants have any question regarding either of the topics discussed, you can either unmute yourselves or you can simply type it in the chat. So you can ask any of the questions you have from any of the topics by now.
I think we have one question from Dilshan Kumarasinghe, who asks us how GPA affects the MSc, right? That's a very good question, Dilshan. But it does affect your chances significantly. Of course, this is what I was saying, right? The GPA is tied very, very coupled very tightly with the university, right? The how recognized the university is. The more recognized your university is, the smaller, like the lower the GPA you can go, let's put it that way, right? The less recognized it is internationally or at the place you're applying to, right? And this is the important aspect, right? If there are a lot of people from Peradeniya, for example, in a certain university, they already know the quality of students coming out of there. That means your GPA requirement you might be able to get in with a little lower. But if you're going to a university which doesn't have any students from there, they have nothing to base you off of, your GPA matters even more. A higher GPA matters, right? And of course, getting into a master's program, I don't know what the scale in University of Peradeniya is, but if it's a 4.0 scale, I would say having above 3.5, 3.6 is something you would really want to target to get into a top tier program. And the closer to 4 you are, the better your chances are. Because one thing I realized is when I went into graduate school, okay, this is something that you guys will realize when you go into a good program. When I went into graduate school, obviously I was fortunate enough to do well in my undergraduate, right? So I went in as a person as, sorry, I've got another message. So yeah, so and again, adding on to the GPA problem, again, as I said, getting into a master's or PhD, more important is research, because that's the more objective metric, right? Because if you publish in CVPR, if you publish in ICCV, if you publish in ICASP, if you publish in ICIP, everybody knows what that means, right? University, they don't know as much. Definitely you need to have a great GPA, that's a must, but having publications matters more. But again, the other thing is, when you get into these top tier programs, what you'll see is everybody in that program graduated either first or second or third in their programs, right? There's nobody below that. So that means obviously you have to do really well. But again, from those, only a few get in. And that is mostly to do with what your research, what you have done in research, right? Have you published anything? Have you actually solved a problem, right? Learning is what everybody can do. But solving a problem and having that problem reviewed by peers is something that is a defining aspect, right? It gives you a little edge over everybody else. That's my opinion and the way I've seen that. We have another question. Oh, sorry.
Hello, sir.
Hello.
I'm a third year student, Praveen again. So
hello, Praveen.
How to in the end of this year we have to go to internship. So
right.
What are the opportunity in internship? How to apply some company like Samsung?
Good question. So Praveen, so that's an important question, right? So applying to internships now, if I might ask, you're locally situated in Sri Lanka, right?
Yes. I
So
like
this
to
is,
apply to foreign internship.
you should try. I say you should try, especially in this time where you have COVID, right? Nobody's going to work. So that might work as an advantage. I don't know. But generally, there are foreign students who work as interns. I know of it, but typically interns are mostly from US, companies get from US, etc. But there is never any harm in applying, as I said before, right? Just put yourself out there. Failure is okay, right? You ask a question, they say no, that's fine. I would say search internships, apply, see what they are. Most of the time, Praveen, the reason you might not get in, if you don't get in, is because of more to do with the company payroll, right? Because when you pay somebody, it has to go through certain protocols, right? Because there's all these tax and all of those things involved. I'm not going to get into those things because I don't know. But sometimes for hiring somebody from Sri Lanka is going to be difficult if you're living in Sri Lanka, because they need to find an entity within Sri Lanka that's going to handle their income, their payroll, the taxation, all of that kind of stuff. But with that said, I will still encourage you to do your application, see what happens, and try it out. And Praveen, if you're interested in getting into a R&D position, internship, not to the chances of getting into an internship with an undergraduate in one of the R&D labs are very, very low, right? Unless you're from perhaps MIT, Caltech, or something like that, the chances are quite low. Or Carnegie Mellon, or Purdue, or whatever of those universities people have heard of here, UIUC. Your better chances are in a master's. Do a master's, come to the US, and then your chances will increase a lot more. Because I'll tell you the reason for that, Praveen, is because, and even if you're from the top university in the US, your chances are not as, in my opinion, are not as good as perhaps a person who's done a master's in perhaps not the top university, because you know more, right? And the problems you're trying to solve in these R&D labs, the undergraduate knowledge you have may not be sufficient, right? And more importantly, you may have the knowledge, but in the opinion of the person who wants to hire you might not have enough. And that's what matters more, right? So my advice to you, Praveen, apply, see what happens. More likely, you might not get in. If you're lucky, you will get in. But important thing is, if you want to work in these places, do a degree from a top tier university, do a master's, do a PhD. That is the best way to maximize your chances, right? And when you're there, when you're at that point, when you do your masters and you're looking for things, talk to people like myself. Ask us, what are the opportunities? Can you help me find something? That's fine, right? I hope that answers your question.
Okay, sir. Good. Thank you, sir.
And especially, for example, in my lab, almost all, as far as I know, everybody is a PhD, and most of the people who are interning in the research aspect are also people in PhD programs. So research labs rarely ever hire or intern undergraduates. It's mostly graduate students. Yeah.
Thank you, sir.
Of course, my pleasure.
Thanks for the wonderful talk.
Of course, Dr. Parakrama.
Yeah,
Parakrama, as I call you.
Yes. That's so nice to see you.
Likewise. No, I didn't see you, but I talk to you.
Yeah. Quick question. Can you elaborate on a little bit on the value of classical signal processing and image processing theory in the day of deep learning?
That's a really good question, and that's a question we deal with every day, right? Because now people now if you look at research papers, if you look at the best performing algorithms nowadays on your classification, etc., deep learning is it, right? And people think that deep learning, and because of that, perhaps rightly, people think that perhaps rightly in certain aspects, deep learning is this problem to solve solution to all problems. It really isn't, right? It's a solution that, and that's where this balance comes in, right? There are the way the sort of analogy I bring in is, if you want to do something, you can always use a hammer, right? That's deep learning. That'll do the job for you. But sometimes using a precision screwdriver gets you the better solution, right? And that's where people, especially thinking about going into graduate school, should really think about things. Deep learning is a tool now. right? Deep learning is a tool that doesn't differentiate you. Anybody with an ability to understand Python and to work in TensorFlow or all of that, they can do deep learning as the traditional solution goes, right? They can apply deep learning to image reconstruction problem and say, hey, I got good results because I stopped training at epoch number 30 as opposed to epoch number 40. I took out layer 5, I took out layer 6. A lot of people can do that, but a lot fewer people can actually do traditional image and signal processing. And where does that become important? Because you don't always get to use deep learning to solve your problem, right? It's not always are you at liberty to use unlimited computational resources. And that means, say, for example, you're solving a problem on a phone, you're solving a problem in a car, you're power limited, right? Your memory limited, your compute limited. So all of those mean that you need to solve your problem efficiently. And also, just because you can solve a problem with deep learning doesn't mean that's the best solution, right? And sometimes people tend to think deep learning will always give you the best solution. That's also not true, because, there are certain problems that when you model them properly mathematically, they will give you a better solution than deep learning, because deep learning, you're sort of going into this area where you can it's based on your training, right? But when you model the problem mathematically, it gives you a better context of the problem, better framing of the problem, and perhaps a better solution, a more efficient solution. And then again, tying deep learning itself into signal processing, that's another important aspect, right? And there was some work that I can relate to that people did. This was called plug and play, right? What they were doing was, for this traditional image reconstruction problems within computational imaging, you're trying to do image reconstruction. What they did was they came up with a theory where you can plug different models in to the different aspects where you were initially doing sort of this mathematical estimation. You're plugging in a deep learning model, for example, and then you can prove that that can actually give you the same solution you were looking for before. So, or actually a better solution, because there is a mathematical framing of the problem, and that framing you're using, within that framing and within that framing and context, you're using deep learning, as opposed to blindly attacking the problem with deep learning. And that's what we need to understand as researchers and future researchers, is that deep learning is an important and necessary tool, but it's not the solution to all problems. And understanding there are millions of people who understand how to use TensorFlow, but there are very few people who understand the theory in image processing, in signal processing. And those people will always have value within the industry, because most problems cannot be solved just with deep learning, right? And the most important part is framing the problem and understanding how to model a problem, and understanding the mathematics that can solve a problem, and also understanding that where you can use deep learning most efficiently, and where you can use other traditional signal processing computer vision more efficiently. And that's where you get most value, right? And Dr. Parakrama, you, of course, you do a lot of research in this area, and you know this. And does that explanation make sense, or anything that you think I missed?
No. I think it's a wonderful explanation. I mean, from a person who has been through a lot of cutting edge industry, I think you have given a lot of insight to why is it still relevant.
Yes.
And it will probably, I mean, I don't know whether you may agree to it, but like deep learning may be a technology which we are passing through, but after a while it may run out of its value, and something else might come and replace it. But the fundamentals would still be valuable even at that time, I suppose.
Exactly right. I mean, you're right. Because important thing is, I was listening to this algorithms course at MIT, some online course, and they were it was a machine learning course, because I didn't do machine learning when I was in grad school, and I was in grad school in 2011 to 2017. And at that time, deep learning was just coming out of the shell, right? And this is the important thing about how cyclical this thing is, right? Not even cyclical, how fast things get out of date. Things come, things go, things come, things go. And what the professor was saying was, they were in fact debating taking neural networks out of that course, because it was becoming irrelevant. And then suddenly, this ImageNet research comes out, and then AlexNet research, comes out, and things blow up, right? So that's the important thing. Deep learning is the thing now. Deep learning may not be the thing tomorrow. But the thing is, as researchers or future researchers, what we need to do is work on the theory of tomorrow, right? Not just the problem of today, right? And in order to attack that problem, fundamentals are the most important thing. You can't come up, the thing is, anybody can use deep learning, but no, not everybody can design deep learning. Not everybody could understand deep learning to come up with new networks, to come up with why is deep learning working and what's the mathematics in there, right? That gets you to the next step. And how can you evolve away from deep learning? Go to the next step where you get into what you call the next direction of research, the next deep learning, if you will. And that can never be done without understanding the fundamental mathematics, right? So in grad school, for example, the courses I took were things like, my professor doesn't let us graduate without real analysis. And he used to make us, some people take measure theory, but not, thankfully, he took out that restriction for us. I took classes in the stat department, in the math department. I think in those I learned so much important stuff that allows me to advertise myself and differentiate myself from people who've done perhaps pure deep learning research, because it allows me to it gives another dimension to saying that I can solve a problem perhaps without using deep learning. And especially in the areas that I've worked in, like, for example, my work at TI, and I can talk about this because this is published research, I didn't do deep learning work. And that's why they wanted to hire me, because they wanted me to do more traditional work, right? More traditional signal processing work, because that's what you can run on an embedded processor sometimes. You can't, you can run some deep learning algorithms, but the thing is, you don't have that compute capability, right? So that's another thing. And then again, as Dr. Parakram was saying, deep learning might be just a phase, right? Might be that phase of research we are in right now, and it might very well become obsolete in the future. And that's why we need to understand the fundamentals, and that's why fundamentals are that much more important.
Actually, it's Roshan here. No, I was just wondering, like when Parakram was saying it, I was just wondering, like, now in your research, I remember, like, you used a certain machine learning. So just to build up on the argument that you and Parakram are sort of discussing on, like, for example, deep learning can support the sort of the distortion metrics that you define there, and sort of improve upon the work from there, right? So I think that is a very good way to sort of build on this particular argument that we are saying, where we use random signal analysis theory, and you supplement that with deep learning, right? So you
exactly that's exactly the point, right? It's all about understanding how to model a problem, right? And the way to do it is exactly as my brother was saying there. You start off by mathematically modeling a problem. You understand the dynamics in the problem. You understand it through random signal analysis or control theory or whatever the theory may be. And then you slowly build upon it, right? We first frame the problem through theory, and then you try to solve the problem first through fundamentals, right? Never start with deep learning, in my opinion. Start with the simplest solution, the more elegant solution. See how that works, how well that works. Then go to the next solution, then go to the next solution, then go to deep learning, right? Or do deep learning, see what the result is, try to see if you can match it with a much simpler and more elegant theory, right? But the important thing is framing the problem. The important thing is understanding how mathematics works within the context of real world problems, right? And that is the key thing that you learn in graduate school, is that if you do, in my opinion, a real sort of signal processing, image processing, thorough degree, what you need to understand is you probably have not solved that problem before when you're going into industry, but you will know what theory can solve that problem. And you will be able to frame the problem within that context. So with that, I have a couple of questions on chat. I'll go through them, and before we go into some more of the discussion, if that's all right. So the first one is from Insaf. He is asking, is it true that there are limited scholarships for MSc? But I've heard students get technical and research assistant positions that they could cover the tuition fees. Yes. Okay, good question. For masters, limited, very limited, because, students, the universities try to keep the teaching assistant positions and research assistant positions mostly for PhDs, right? Because those are the guys they have to keep for longer, that have to pay for longer. And those are the people that are really making a big investment on, right? Because they need to keep them for a while. And they want to give them these kind of opportunities so that they can focus on their research. So you might get a scholarship for masters, but the chances in a very good university are lower. But, based on the university, you might get one. But Of course, another thing that people do is come into the university first semester, you pay it, and then what you do is you get a teaching assistant position after that. So there are different avenues to attack that problem. And if you need more information, you are always welcome to reach out to me on LinkedIn, perhaps. This is from Dr. Vijita Herath. I think it's from the Dr. Vijay Herath, or it's a student, I'm not sure. But the question is, what mathematical tools do you recommend students need to master to do imaging research? So mathematical tools wise, random signal analysis, signal processing, which is signals and systems, those are the essentials. Then you have your sort of geometry based ones, which are sort of like these perspective transforms, affine transforms, understanding that kind of stuff, right? That are essential for sort of the optic side of things. And then, of course, your optics, which are more on if you're really in the optic side of the image processing. And that's the thing, right? Image processing also covers this vast area of subject matter. But the most important things are understanding your optics, understanding statistics, which means random signal processing, probability theory, signals and systems, and signal processing, because imaging is just a 2D signal processing problem, right? 1D signal processing translates to 2D signal processing. So to just give you an understanding, when I was talking about that random sampling problem that I was doing, my professor first told me, before you start with an image, I want you to solve that problem for a time series signal, assuming that you can sample in time. How do you do that? So that's how you expand on these things, right? You understand 1D signal processing, 2D, then you go to 3D, and then whatever you need to, even 4D if you're working with 4D. So the just to give a quick answer is mathematics in this form of statistics, random signal analysis, systems theory, and if you have image processing courses, video processing courses are all essential. So next question from Kalindu. What are the good research areas in computer vision and computational imaging for a final year undergraduate project? Very good question. And that's a very broad question. But what I would say is read within the context of some of those areas that I showed, right? You have if you want to go into computer vision, in computer vision, most of the undergraduate level problems you might be solving are with deep learning. You could do some of that deep learning work for things like semantic segmentation, for image classification. But I have to warn you that when you're doing computer vision and trying to show outputs and compete with the CVPR publications, one of the disadvantages you will have is you will not have access to the same computational resources that some of those folks have, right? So some of these folks have supercomputing clusters to work with, you have GPU clusters to work with, you might not have these opportunities. So perhaps a better entry point for you might even be in the more traditional areas, right? Do some of the imaging research, do some of the computational imaging, which is computational imaging. I would advise you to sort of understand some of these sort of things like map estimation, ML estimation, those kind of problems. Those are things you could do. And even things like, not to advertise my work, but you could start thinking about new problems like dynamic sampling, right? Like my brother was saying, now we were talking previously about how I solved the problem, but I know my solution was the most trivial solution to the problem, because I started working on that project, and when we did it, there weren't many publications in that area, right? We didn't have anything to cite, so we just cited some random work here and there, and I solved it with what do you call that? The most simple machine learning, which is linear regression, right? So that's the simplest thing. Put a deep learning engine in there, solve the problem, get better solutions, publish, right? And then I did greedy sampling. What about doing something better? Do reinforcement learning, right? You might know, you've heard about reinforcement learning. It uses deep learning to solve certain aspects of it, but it's a more theoretical, rigorous problem, right? It's about how you frame the problem in a completely different way. So think about a problem like what I did, try to put it into reinforcement learning aspect, try to solve that problem through that, right? So that's the other thing. Read about, so if you want to get into this research, the best way to do it is go on Google Scholar and just read a couple of papers, or just go into these blogs. There are different blogs that these computer vision researchers, imaging researchers have. Go to their Twitter accounts even. They might have some things they talk about. Just be academically curious and then go and talk to, and you guys have these professors, these lecturers, senior lecturers who have done amazing work. Talk to them. They will have problems for you to work on. I can give you guidance on saying, hey, think about these things, but you have amazing resources there who've gotten degrees from the best places in the world, and that's one of those important resources that you should always look into, because these are people you could just knock on their door and talk to them. Use that opportunity at their convenience, of course, and ask the questions. They might have research areas for you to work on. And always when you're doing a research problem, it's always good to have guidance, right? With an undergraduate degree, with what you've learned, you might be able to do some things, but with guidance, you might be able to do a lot of things, right? And that's the other thing about getting publications. If you as an independent researcher put a publication to CVPR, this is the thing, right? Academic bias is there. People are going to look at who you work with, right? If you come out of if the people don't know anything about you, they might not give you the same attention that they might otherwise give to people that you might work with. The resources you have within the university, work with them. That will give you the best opportunity of doing research. So my advice to Kalindu is talk to your professors. They are the best people who can tell you what research to do and how you can do that. So next question from Akita Patirana. I'm just starting out deep learning. I'm following the deep learning specialization from Andrew Ng on Coursera. During my undergrad period, what kind of projects do you think I can do to get a good grasp from industry applications in computer vision? So again, the problems you can do is, understand how you do, if you are in sort of, what do you call that? Image classification, semantic segmentation, object detection, handwriting recognition. Build up a Git repository of code that you've written, right? If you want to get into these software companies and stuff like that, it's good to put your Git repository as a link on your resume, right? So that people know that you're not a guy on, and again, not every one of you is wanting to go into research. Some will want to go into development. Some, that's an important aspect, right? So for that, you need to show people you've done this stuff. So create a repository of the work you do and let people have access to that. Contribute to open source if you can. Contribute a bit of code. Those things matter to you as well. So industry applications are image recognition. For example, let's say you're working for a company which has a production line. You might want to use, so for example, you have a conveyor belt and you have a piece of something that you're manufacturing, you want to see defect identification, you could do that. You could do handwriting recognition. Do some of those things. Build a portfolio of code for yourself. That might help you in the industry, right? And also in your applications. And also these are the things you mention in your SOP. And also your statement of purpose, and also in your resume. I've implemented this code. I've seen results. I've done this before. That's important than saying I could do that before. Next question.
Guys, one thing because there are a lot of students have been asking about the project-related stuff. So maybe from your observations, you can say something about on one side, the virtue of our students have what is called a final year project, right?
Yes.
Yeah, they do 2-3 credit projects for the 7th and the 8th semester, right? So there, one thing is you can talk about for example, what would be beneficial for them to do, let's say if they want to impress the international industry, would it be better to sort of do a project that showcases the use of tools versus a project that showcases the ability and the analytical skills, right?
Yes.
So that's one thing. Another thing is probably the virtue of doing multiple projects, maybe extracurricular projects, like even before you get started on the final year, because there might be second years, third years here, right? So for example, doing something like that, is that important? And in that sense, for example, having publications, does that matter? So that kind of groundwork might help, because I'm sensing that there are a lot of people who are curious about these projects from the line of questioning that you are getting.
Absolutely. So yes, absolutely. So when you're looking at research positions, it's if you're looking to go to grad school, right? Having projects that showcase your analytical capabilities or your mathematical capabilities are always going to be in higher demand. And but the thing is, you have to balance that out with your deep learning as well in this day and age, right? So the best research you could do is where you define a problem from start, you solve it using different tools available to you. First, the mathematical modeling part of it, the statistical analysis, the statistical signal processing aspect of it, and then trying different signal processing approaches, then doing deep learning. Basically, having a full understanding of a problem, if you can show that mathematical understanding as well as deep learning understanding, having all of those together might be the perfect project, right? But if time is a limitation, perhaps what you want to do is, in my opinion, try some of those signal processing, image processing traditional problems. They're important, but then it always, again, it really hinges on what you want to do. If you want to become a deep learning researcher, do the deep learning problems. But again, try to not just say, I implemented this network on that. That is probably not going to get you into a good place, right? The important thing is going through the problem from the basics and building yourself up, and then use deep learning to solve the problem also. But that should not be your end all solution. And if that's the case, there's a million of you out there. So that's the key, right? The key is understanding the mathematics behind the problem, showcasing that you can understand the mathematics behind the problem, that you could model the problem, and then also showcasing that you could solve the problem with deep learning, right? Keeping those two in balance gives you the best shot, right? So I think that might be the perhaps answer to that question.
Yeah. And also the extra projects, right? Like
yes.
doing something in a
Exactly. So this goes to that question about what the other student who Akita asked also, right? It's about having a repository of things you did. The repository of things you did comes in the form of publications, comes in the form of Git repositories and publicly available Git repositories, right? So if you have done projects on your own, like Akita was curious, what can I do? And Kalinda was also, what are these good research areas? Find something, apply some, even, do something very similar to what people have done. Work with some deep learning PyTorch models that you have, modify the network a little bit, see how it works, have that code in there and publish that code in your Git repository so that it's publicly available and people can access it. And this all goes down to curiosity, right? When people think about you, they think, okay, what has this guy done? Is this person able to, is this person curious, academically curious? What have they done, right? He or she might have explored problems on their own. So that's a good thing, right? So you don't have to wait for a grade to be assigned to the work you do. You can do things on your own, explore problems on your own, and build up that repo of things you've done, right? Things you've done is the most important thing here, right? And build that up. So moving on to the next question, we have from Dilshan Singh, how MSc and MBA affect your career? That's a very good question. MSc and MBA are quite different, right? So let me restart again. MBA, if you're trying to do an MBA in the US, for example, extremely costly, right? I was exploring doing that last year. It costs about $100,000 and no scholarships, right? You have to pay out of pocket. So very, very, very expensive and very, very, and you don't want, in my opinion, you don't want to do MBA out of undergraduate. It's useless, in my opinion, right? Because MBA isn't a subject matter degree, right? It's learning to manage, right? Learning to manage means you need to have experience in managing or experience in business before you even think about doing an MBA, right? An MBA with just an undergraduate is not very useful. You can do that and you could get into things like management consulting, and that means you have to get into one of the top MBA programs. That means you need to get into Wharton Business School or Kennedy or one of those, right? So if you get into one of those, that's great. But again, cost at Harvard is about what, $200,000, right? It's ridiculous. So that's the important distinction there. Do some industry work before thinking about an MBA. MBA is a form of getting a promotion, and it's a tick mark that you could say that I did an MBA so I can move forward, right? So I would seriously consider doing it after starting your career. MSc is different. MSc you could do right after your engineering degree, right? And again, you can do an MSc, get into industry, and then do an MBA, right? That comes later, right? That's in these engineering firms, things work very differently, right? So my Texas Instruments CEO, when I was working there, he's an electrical engineer, right? He's a bachelor's in electrical engineering, and I don't think he even has an MBA. He's the CEO of a $100 billion company, but I don't think he might have one, but he might have what's called an executive MBA that you do very later on in life, right? That's like when you're like 20 years in the industry, you do an executive MBA. So MBA is good, but MBA is better done later. MSc is if you want to actually work on technical problems within industry. I think an MSc is almost an essential thing nowadays. A lot of people end up doing MScs, and then after an MSc, work in the industry for a little while. If you think management is the route for you, and if others think management is the route for you, do an MBA. Most likely your manager will tell you, do an MBA. That's what happened to me. They said, do an MBA, think about doing that, going into management. Then you do an MBA, right? That's my advice to you. And that way you'll have, working in industry, you'll also have the money to do an MBA, because MBAs are extremely costly. Next question. So what do we do to get a scholarship? I'm a first year student in UP. I like to study up to a PhD. One answer, two answers, right? Good GPA, more importantly, good research. Start early, start talking to your professors early, start getting advice from them early. If you can't get access to your professors at the beginning, which is entirely possible because they're busy people, talk to people who are in the fourth year. Talk to people who are fourth year students who are doing research. Ask them how they went there, how they started their work, right? How do they approach it? And ask them, hey, can I do a small part of your problem? They might like to get somebody's help. That's how this is, right? Research works like this. A professor gets graduate students to do problems, right? And some things that the graduate students might want to get undergraduate students to do some part of the problems. So you have to start at the bottom and work yourself up, right? And that's the key. Insert yourself into somebody's research. That's how you get yourself in there. Right? And think about your plan forward very early. And there's the people who get into the best universities are not the people who have the best GPAs, are the people who did the most research very early on, right? Because everybody in the top 20 universities will have amazing GPAs. But the one in the top 1 university is the one who's done the most research. And that is absolute key, right? So that's my advice to you, Rex, right? And next we have from Dr. Vijita Herat, what sort of attitude students should have to be successful in graduate studies? So the biggest attitude, the most fundamental attitude that you should have is, I don't know anything, right? And that's key. You really know very little. And curiosity, right? Wanting to learn from other people, being able to read papers, being able to understand papers, spending time understanding those things, and understanding that you probably won't get results for a year. It's an exercise in humility, right? You start off with undergrad, you did well in your class, you think you know everything, but you come into graduate school and you are given a problem you know nothing about, or you think you can easily solve it, but then you realize that that's not the case. So what you need is two things: understanding that you know very little and there's so much for you to learn, and then having the curiosity to follow up with that, right? So those are the two most important parts. Next, I have from Vihanga Herat, are there possibilities to get a job in the US or Canada with a BSc without industry experience? Very little. Possible, very unlikely. I know people who've done it, but that's a long time ago, okay? So let me tell you something. Canada works on a point system, right? So that means either you have to get a job that will directly hire you into a visa program, or you have to come up with a come into the permanent residency program and then get a job. Permanent residency, I don't think with undergraduate degree, you have enough points to get into Canada or New Zealand or Australia. I think, okay? You need a little bit of industry experience for that to get the sufficient points. Getting directly into a job, again, it's the same thing, right? Why? You have to always ask the question, why would they go through the trouble of getting somebody from Sri Lanka? I'm not diminishing what you've done, right? I know how difficult it is. I know how difficult it is to get into the university. I know how tough the program is, but that is you and me, right? But the person who is hiring you needs to ask that question of themselves. If I get somebody from Sri Lanka, that means I need to sponsor a visa for them. Immigration visa. I need to go through that process. Delay of 3 months. You have to be really exceptional for them to spend that time on you, right? It's an investment problem. Where do I put my money, right? So if you're investing in stocks or whatever, you have to understand where you're getting the most return on your investment, right? These are businesses. Businesses care about money, making money. And that means you need quick results and you need the best results. So do I go with somebody who went to, let's say, Canada, for example? Do I hire somebody who went to McGill I know about, right? Or do I get somebody from Peradeniya I don't know about? So what is that additional bit of qualification you bring in? So my answer is, out of an undergraduate degree, your chances of getting into an industry position in one of these countries is very low, right? And that's not to diminish your expectations. That's to motivate you to work harder, right? Motivate you to work harder, get into industry, do a master's, try to get into a master's in one of these countries. That will make your chances a lot better. And PR works on points, right? So having those MSc points, PhD points makes a big impact on your permanent residency application. So next question. Okay, that was from Vihangan. It is from Chamika. Can you tell some about your failures and get, yeah, absolutely. So what things I've done well, what things I've not done well, right? One of my biggest failures is I didn't do undergraduate research, right? I really didn't. And this is something the reason I bring it up to you guys all the time is because that's something I did not do, right? And that's something that will impact my graduate studies when I was applying for universities. There are people who graduated with the same GPA I did who can get into a better rated program than I did, right? Obviously, I didn't get into the #1 university. I got into something around 7, 8, 9, right? So that means there were things that people had that I did not have. And that is research, right? So there were two, give you an example, myself and another girl, we both ended up with, we were both top graduate #1 in the university, but she did undergraduate research. I did not do. So she's at MIT, I was not. So that's the clear thing, right? So this is what you need to understand. And that's what we are here for. People like us it's not just about the things we did right. It's also about the things we did wrong. And that's what I want you guys to learn from. Don't do the same mistakes we did. Try to take the step that we couldn't take. And that's our responsibility to the community to tell you guys that, we got this far, but there's much further to go. If you do things that we did wrong, you'll get there, right? And next thing, online courses have a significant impact. Of course, yes. Having that knowledge is useful for you, and especially for when you apply for jobs. It might not be that useful doing online courses for grad school. I don't know. But I think for industry, it's definitely useful. And also online courses will help you understand things that are not taught in your universities, right? So next question is there any added advantage when applying for an MSc if you're involved in sports and societies? Yes, of course, those things matter, but they're not the ones that matter the most, right? Because what we have to understand is our MSc programs are in academics, right? It's in electrical engineering. So most important part is your academic performance, but having those societies, having those leadership positions always makes an impact. For example, I think in the Berkeley application, they ask you to write 2 SOPs. One is about sort of your leadership activities or charitable activities that you've done. And the second one is on your academic activities you've done. So that balance is important. But actually, in the US at least, those things are most important when you apply to undergraduate programs, right? So it might not be as important for master's programs, most important for undergraduate programs. Because if you're trying to apply for Ivy League university, for example, having those extracurricular activities are essential. So next, you mentioned 3 key factors which could be used to rank a PhD: professor, topic, and university. This is from Suren. In your opinion, is there any similar metric for an MSc? Very good question. For MSc, I think the professor doesn't matter as much, but again, you can do 2 forms of MScs. You could do a thesis MSc and non-thesis MSc. So if you do a thesis MSc, the answer to the question is different from a non-thesis MSc. From a non-thesis MSc perspective, the most important is, one thing is rank. The other thing is how many of the people in your university are working in the company you want to work in, right? That's an important distinction. So what you can do is you could go to LinkedIn perhaps, and then let's say, for example, you want to be a software engineer at Google. You go to Google and then you can see how many people are, you might, I don't know whether this is possible if you're not from that university. So for example, when I'm in Purdue, I can go to Google or Samsung or something, and then they'll tell you how many of people in my university, in my network are there, right? So that'll tell you how much of an importance, how much of a network you have there, right? Network matters a lot, right? So, for example, Google might not come to every single campus to recruit. They only come to select campuses, right? When I was at TI, TI has relationships with certain universities, not with other universities. Samsung might be the same way, right? It's people always want to get the best, right? And the easiest way to get the best or to decide the best is based on ranking. So that's why I think master's ranking might be more important. And if you're doing a thesis research, thesis masters, then your professor matters as well. So I think that's everything I have on the chat. If there are any other questions on the live discussion, please.
Dr. Dilshan, yeah.
Yes.
So another question. So when you go to this website, there are multiple websites online where you find different university rankings.
Okay.
In my opinion, I would say like for bachelors, this would make more like these rankings are more and more, solid. But when it comes to grad school or PhD or mostly PhD,
Yes.
the area in which you do research, it would have a higher, ranking, have higher priority as well. For example, the university like Simon Fraser, it would be very good for computer vision and deep learning. However, it's ranking like below 100 or something.
Exactly.
How would you say we could, filter out or, find out which is the best option for you?
That's a very good question, Suren, and that's an important distinction, right? So as you were saying, Simon Fraser, or for example, take Rice University, which is in Houston right here, right? Rice is not rated high for electrical engineering, but everybody knows that doing image processing or signal processing in Rice is a big deal, right? That's the thing. So DSP is good in Rice, and the best way for you to know that is talk to your professors, right? The lecturers, they know what these are, right? The top rank doesn't mean anything if you did useless research in the program, right? Or if that program is not well represented within that university, right? And that's very important. You might go to a top tier university who has 2 professors in that field. That means nobody will recognize you. And when you get into the industry, the distinction is the network. You might get a better network with certain universities based on rank, because there's a lot of people working in that area. And then rank is also, it's an electrical engineering rank, right? What does that mean? That means it averages over power, control, nanoelectronics, signal processing, machine learning, everything, and gives you one number, right? That is not the most important thing. The most important thing is, especially when you're choosing a PhD, who are you going to be working with, right? But I have to always bring the distinction, but name of a university does matter also to an extent, right? Because I had a colleague at TI. He was, I don't know whether you know the guy who did the signal processing book, Oppenheim and Wilsky. Oppenheim student at MIT, right? So him and I, we were very good friends when we were at TI. And we used to have this discussion about the importance of rank in getting into things, right? And about people's opinion. So it's mostly about opinion, right? So if, for example, the way I see it is, now if somebody tells me they went to MIT, I think there's a 95% probability that you're a really, really good student, right? Then let's say somebody said you went to Purdue, for example. I would say 90% chance that you're really, really good. Now, let's say we take something which is this is a very general thing, right? This is without knowing anything about the professors or knowing anything about the program. And then let's say I talk about somebody who's in the top 50 program. I would say, okay, there's about 60-70% chance they're good. But the important distinction is there might be somebody in the 150th ranked university who's way better than somebody at the number 1 university, right? And that's why it's a probabilistic game. And that's what happens in hiring also, right? I think, because people make their initial judgment based on certain easy to evaluate criteria, right? Easiest to evaluate is, okay, oh, this guy is from MIT, so he has to be pretty good, right? But then that might not always get you to where you want, because sometimes your job, the industry R&D, as Suren, what you're saying, in that name doesn't really make that much of an impact. It's about who did you work with? Who is your professor, right? Is that professor good in that area? What are your publications? It doesn't matter whether you went to Stanford, for example, if your work is not up to par with somebody who went to a lower ranked program. So it's all about what you did within the context of your PhD, right? But what the name gives you, what the ranking gives you, is an initial understanding, and perception matters, right?
I mean, just to expand on that, Dilshan, from Suren's question,
yes.
Do you think when the person after graduating from like the PhD and going to academia, yeah, the research, the the supervisor, all of that might, I'm just putting it out there, right? Will it matter more than, for example, them getting a PhD and the rank recognition, for example, if they're going to work at Facebook or Amazon or TI? Just to put the question in context, now this I do not know. It's like from your experience, you can just count the people. Like let's say if you go for TI, if you go for Samsung, or if you go for Facebook or Amazon, like do you see a higher spread of people from high rank universities, or is it very uncorrelated, like very random sample?
So that's a very good question, right? So it's highly correlated, right? And that ties back to that whole probability thing, right? It's about where do they care to recruit from, right? So people can apply to all of these companies and get in, but there are places they actively recruit from, right? So for example, Microsoft has a big tie with Carnegie Mellon, right? And that's why Carnegie Mellon is the #1 rated university for computer engineering, right? Google has a big collaboration with Carnegie Mellon. That's it. They recruit from there, right? And they like to get most people from there. Now, for example, if you take Purdue, we have an active collaboration with Rolls-Royce, and that's because our aeronautical engineering program is one of the best in the world, right? So and then even our electrical engineering program we have with certain of these big companies, and we have, I can't obviously disclose where we recruit from for the different companies because that's beyond the purview of what I'm allowed to talk about, right? But generally speaking, there are candidate universities that people actively put money and effort into, right? So if you go to these universities, you will see there are buildings named after companies. Why do they bother doing that? The reason they bother doing that is that they want people in those top tier universities to see that name and correlate that, okay, this is, and try to lure those people into those particular companies, right? So definitely there's a correlation. I mean, that's not to say that you can go to any university and you can go into any of these companies, entirely possible. But I would say getting into the more prestigious companies, the more prestigious labs, it has a correlation of where you went to. And then to that, because it's a correlation, and why I don't say it's sort of a causation is because it's a very intricate problem, right? The reason these universities are ranked high is because they have great professors, right? And that's the thing, right? So it's because of the professors, it's because of the universities, and the reason the universities are ranked high are also because of the professors. So it's sort of a chicken and egg thing, right? So it's a cyclical thing, right? And importantly, that's what you get, and because of that, you might end up in a better place, right? And you might and working in research labs, I've seen that most of the people are from the top universities, right? And that's not to say that the other people didn't do good work or whatever. But again, to that point of what Suren was saying is, I've seen very good example is, for me, because I'm not in computer vision, I know more about DSP, Rice, right? Rice is not ranked at the top there, but in all of these places, I've seen people from Rice, because Rice has amazing DSP program, one of the best in the world, right? So it's a very subjective thing based on the different part of the organization you are, and it also depends on the organization and where they spend the most money, right? And then you can look at these hiring statistics. If I don't know whether they're available to the public, but when you look at them, you see some sort of correlation sometimes, right? And that doesn't mean that they're saying, okay, we need 5 people from top 1, top 2. No, not like that. It's just that the demand is higher when you're from a bigger, like a more reputed program, and that's always going to be life, right? And that's going to be based on ranking. That's going to be based on professor.
Okay. Yeah. So I have a few more questions if you have time.
Yes.
Okay. Yeah. So many people claim that MS is a good stepping stone to PhD, and like you can since PhD getting direct in PhD is very hard, MSc might be good, just like you did. But the usual thing that like I noticed this happens often is like people rarely go to a different university to do a PhD. Like when you do MSc, you usually end up at the same university doing PhD. So this might be due to different reason. One reason that I think is because once you are more familiar with the professor, it's much more easier to work with him. And this brings me to another question. But yeah, putting that aside, so in that case, have you seen people who do MSc at one and then move on to PhD to a different university? Does it happen much as often?
So let me answer that question first, right? So I actually started, Suren, as a direct PhD. I did an MSc So the reason I did an MSc was very different.
Yeah.
So the reason I did an MSc was because when you start doing a PhD, one thing people realize is just in case the PhD doesn't work out, you take an MSc.
Yeah.
Okay. So, right. So
just to interrupt it. Yeah, I know that in US the situation is much different where you go for a 5-year PhD and get a MSc from 2 years. So I'm not talking about US, but generally where people particularly go to MSc. For example, let's say in Canada there are certain universities which have MSc. There are certain people I've seen who have gone to UBC and still got an offer to, let's say, these higher ranked universities that you mentioned, but still they decide to stay at a university like UBC.
Right. So I mean that's of course a choice, and I'm actually trying to find an example for you. Give me one moment. Let me see whether I can find that example for you. Unfortunately, I cannot. But anyhow, but what I was gonna say is, yes, you're right. So what most people do is, this is, I think, relevant to Canada and relevant to US and most places I know of, is that there are different ways of applying, right? You can either go to a direct PhD program, in which case you're doing that university, you're staying in that university, you get your master's there, you get your PhD there, whatever. The other option is you go to a reasonably ranked university for your master's, you do well, and then you go to a PhD. This is entirely possible, right? I know a lot of people who've done that, and I've known a lot of people who get into very good universities based on that.
Okay.
Right? But that again depends on, you have to make that plan, right? You have to make that plan that I'm only doing an MSc and this is for me to jump to the next year, right? And this is the bottom line is, some people choose you do a master's and you might get into a quote unquote better ranked program, but you decide to stay is because the devil is better, right? And that's the idea, right? Because the kind of thing that you're getting into, the professors there, and you're going to do some amazing work here, and you realize that ranking isn't everything. Right? Ranking is just a metric. It really, in the grand scheme of things, it might not matter at all, right? If you're doing really good university, for example, your example was UBC, right? If you're doing very good research at UBC, you don't necessarily need to go to a better rated university than that. It doesn't matter, right? In the PhD, what matters most is what you're doing. And the easiest metric to understand that is ranking. But if you're already in that program and you've already understood what master's research in that entails, and what your PhD opportunities are, and what professors you get to work with within that university, that becomes a moot point, right? You already know what you need to get into. And that's basically a determination you need to make for yourself, right? Because when you do your master's, you will understand whether this is the place I want to do that, continue my studies in. And that gives one other aspect of that is, then you can plan your future within that university itself, right? And you can get into a master's program. After a little while, you can apply to a PhD program to convert it also, right? So that's another possibility. But typically getting into a direct PhD program, at least in the US, it's a harder problem than getting into a master and then a PhD. But then the difference is, typically when you get into a direct PhD program, they also give you a method of funding. Whereas when you get into a master's, you don't always get that. But within the context of Canada, I can't really say much because, I've never been there. And all I know is like sort of third hand or fourth hand knowledge, or second hand at best, right? So it all depends on the country. It all depends on what you want to do. It also depends on what your aspirations are, right?
Okay, yeah, I get it. Okay, so the next question is regarding this PhD professor. So as I said, one of the problem, like choosing a PhD professor, while if you go direct, sorry.
No, it's okay. Please go ahead.
So if you go to do this MSc and PhD together, you have this opportunity for the first year where you can scout out different professors and then choose someone, because it's not just the research that matters when choosing professor. You should also be the human aspect of the professor that comes into matter. And there are also other factors, like, for example, say a particular professor is good in a particular field. However, now he wants to expand, and although but still he might not be experienced in that particular field. For example, now that since deep learning is becoming a hot topic, I know that there are certain professors who actively see people who are willing to apply deep learning in their particular field, though they don't have though they don't have particular knowledge in that particular field. For example, like communication or different fields. I don't know. But so there are certain risks associated with this when you are going to a particular, like a professor like that, without knowing the professor. So in my opinion, like many people say, the best way to do this it's like directly talking to the students and getting to know idea what is the best way to know about the professor himself. Do you have any other like ideas of how we can, choose a professor properly?
Good question, Suren. And I mean, so you just to understand the question is, before you get into the program, like, not the context of you're in the program, like you have entered the university and trying to find, but you're external and you're trying to find professors.
Yeah. So in your case, if you're going for a master's plus PhD, you'll have this 1 year part-time period where you can, choose this. That's the greatest advantage in US, where you can, choose
right.
depending on your, his human aspects as well. We discuss with us. So you won't see this on your, on your Google Scholar profile or his personal page. These kind of things can be.
Right.
Yeah.
So the best advice, Suren, is obvious. I mean, definitely there's no better way than talking to somebody in that lab, right? And I mean, there's really no better way. You can talk to the professor, but trust me, most professors, unless you're already in the university or trying to communicate with them from outside, you might not get the same response rate that you expect, right? They might not spend time with you, right? So one of the things is professors' times are very, very limited. They don't like, they don't respond to emails. Most of them don't really care to respond to emails, right? I've seen that personally. I've seen professors delete emails without, caring about it in the least bit. So you can try to contact the professors. They might talk to you. If that's the case, awesome. But typically, so unfortunately, the only best advice I can give is either talk to students who are actively working for the professor or talk to students who've graduated from the professor, right? Typically, the people who graduated from forget the worst parts, okay? And they remember the good parts. So you are going to get a distilled message. But if you talk to somebody who's there, who's struggling at that point, you get the best picture, right? So if you talk to me, I might sometimes not tell you about the worst. I might only tell you about the best aspects, because, it's the human mind has a way of forgetting bad things and remembering good things, right? So that's just how the mind works. So that's why I say best is to talk to somebody who's actively struggling through the process. No better person.
Okay, sure. One final question. So about this ranking business. So there are different websites which rank different universities in different manners. They use their own metrics to that. So one thing that I have noticed is that, like particularly when it comes to country-wise ranking, there is a little bit of bias. For example, most of the US ranking websites, they rank US universities pretty highly in comparison. Whereas you go to Shanghai ranking, you find a lot of Chinese universities on the top. And then there was another Indian ranking where there were a lot of IITs on top. So similarly, there are different universities which rank. So I didn't find any European. I couldn't find anything particular like that, but because of language barrier and such, maybe.
Right.
But so there are different rankings. So is there something that is an overall good one, or like what's your opinion on that?
Good question, Suren. I mean, again, the ranking, I think the world ranking, I think the one that's, I don't follow this much, so I'm not the best person to ask this question. I know QS ranking is something people look at for world rankings, and it's sort of unbiased. But yes, there is bias based on the place, and that's always going to be the case, right? And it's both. Like if you're working in the US, for example, you're like, if you're within the US, people just look at US news, right? Because that's their best ranking. That's the one they can go off of, right? And it's I would say just take an average of those things. Just look at things objectively. US ones are going to be biased on US. Canada ones are going to be, Canada doesn't have one, but let's say, for example, the Chinese ones are going to be, you said, biased on Chinese ones. That's the case. So you approach that with a prior model, right? That's the idea. And then you make your estimation based on, the prior understanding of how this ranking came about versus the measurement that you have. And then you come up with a proper estimation, right? So my best judgment on this thing is, you first select the sort of countries you want to go to and do this, right? Rather than going on world ranking, go to, let's say you want to go to Canada and the US, go to the Canadian ranking of those things. Pick out the best Canadian universities, apply to those. Go to US News, find the best US universities, apply to those, right? But if you're shooting across the board, go to something like QS and figure out the best ones and apply to those, right? That's an option. But that's best ranking, better ranking. This is really a problem for a person who really knows about it. I think the bigger focus should be on what is the field you want to work in, what is the published research there, right? Ranking is just a number. As a PhD student, as a prospective PhD student, what you should be most focused on is the problem you're trying to solve and who are the best professors for that, right? Go to their Google Scholar pages, see the number of citations they have. Number of citations does not mean everything, right? Of course, there are certain papers that have 50,000 citations, and that person might have another 10 publication, and that's it. So take things like H-index, I-10 index, understand those things, read some of those papers, talk to people in those fields, see where the respected researchers are, right? See where, the research lab you're interested in, where do they hire from, right? Think about the locality, right? So, working in California. So for example, if you're in California, right? If you go to Berkeley or Stanford, what's the importance of that? It's right next to Silicon Valley, right? You have a lot of alumni there, right? So you might go to University of San Francisco, which is not a good, like one of the best rated ones, but that's right there in Silicon Valley, right? You might get a job there easily, right? Rather than going from somewhere else. So those things matter as well, right? So for example, let's say you're in Dallas, we might hire from local universities because it's easier, right? So all of those things matter as well. And that's why, that's for the hiring aspect, but for the ranking aspect of it, there's no good ranking. And you shouldn't focus too much on rankings, right? It's just one metric. So it does not describe it. It's mostly the professor if you want to think about a PhD, in my opinion.
So even for MSc, are you suggesting the professor?
No, for MSc, rankings matter a little bit more, right? But again, when you're applying, don't just apply for the top programs. The best way to do it, in my personal opinion, is select a few from the top 10, select a few from 10 to 20, do a thing from 30 to 50, maximize your chances, right? And think also about which universities hire most internationals, right? Certain universities have more international students than other universities do, right? Those things matter as well. Think about who's going to give you a scholarship, right? So, and remember, everybody applies to MIT who can get into MIT, right? So think about logical things like that too, right? So your chances of getting into MIT might not be as good as getting into number 3 university because not as many people apply to that. So maximizing your chances, and the budget is important, right? $70 or $50, I don't know what the admission fee is. That might be a lot of money to a lot of people, right? And understandably so. So maximize your chances, and again, understand your capability. And the best people who can help you understand your capability is your professors. If your professor tells you, your senior lecturer or professor tells you, you can go to MIT, you work 2 more years and do this problem, listen to them. Because they know what they're talking about, right? Just like me, either they went there or they went to something slightly below us, slightly above or whatever, based on the field you're in, right? And based on that, they have the knowledge that you might not have, right? They might tell you, work another 2 years, work another year. Yeah, or they might say, yeah, you're ready to apply for this. And then they will also, and the way they can get that understanding is not looking at your GPA. It's if you work with them. If you work with them on research. And they work with other people from industry also sometimes, right? And also from other countries. They might be able to give you recommendation letters. As a matter of fact, I worked with a couple of students in Peradeniya over the last year. Through my brother and through Dr. Parakrama, and as a consequence of that, I was able to write a recommendation letter for one of them, right? So, that's the key. Research, right? Do research, talk to people, they'll tell you what to do, right? They'll give you an understanding of where your maximum chances of getting into are. It's always good to shoot for the stars, but you have to understand you only get a few bullets, right? So getting them right is more important. And that's where people who are knowledgeable about the subject are the people you should be talking to, right? And though in a general context, I won't be able to tell you, if we talk on a personal level and you tell me what your aspirations are, where you are, I might be able to tell you what might be a good place for you to think about, or what else might you need to do to maximize your chances for the next step, right? And also I'll be able to tell you, apply to these universities, these might be good. And, I'm not an academic. Academics know more about these things than I do. So your professors, they'll know the better answers than I mean, for these particular questions. And utilize that my key is that I'm trying to tell you is, this is something I didn't do when I was in undergraduate. I didn't use the faculty efficiently. I was concentrated more on grades, right? Because in my opinion, that was the most important thing. But one of the more important things than that is talking to the people who know about how to get to the step that you want to get to. Because these professors of yours, They've gone to great schools. They've worked with the best minds. They know people where people have landed. They know what people's capabilities are. And then more importantly, they go through thousands of students like yourselves every year, every couple of years, right? So they've been through this. So utilize that, and don't use the rankings just to get an idea, but ask people who know. Asking a question. There's no better way to get an answer than asking a question.
Okay, sure. Thank you very much.
Of course. And I have another question from Achala. So I will probably have to end in about another 10 minutes. So I'll answer this question and then we can see whether there's. So you have mentioned some of the statistical signal processing algorithms you have used during your research. So what are some of those things that I've used, right? So, things like particle filtering, things like map estimation, ML estimation, things like, what do you say? So the topics in statistics that I've used in sort of mapping problems. There are things called one of the things I've used and published is something called Dempsey-Shafer theory of something. I can't remember even now. And you have these tone mapping algorithms. You have exposure control algorithms. All of these are based on some mathematical theories, and algorithms is a very broad question, but generally speaking, everything you learn in your undergrad or perhaps mostly in your master's, but I've seen that your curriculums have a lot of the algorithms that are being taught in some of the master's programs. So you have a leg up compared to most people there, because I've seen some of the programs that my brother and Dr. Parakrama are doing, and they cover a lot of the topics that you might end up doing in your master's also. So I don't know about what the other professors do. I'm sure they do similar things. So, bottom line is understand those things well. You never know when they're going to come in useful. As I said, I learned particle filtering in a video processing course. I applied it in mapping, right? So entirely different problems, similar mathematical background. But the key is learning them thoroughly, understanding not the application, but the mathematics, right? So any other questions before I probably have to sign off in another 10 minutes or so?
Yeah, I think I have just one thing, Dilshan. I think we're talking about one thing which is very important, which is like where you learn something somewhere and you apply it somewhere else. And this, I believe, is sort of like better rooted if you understand the basics properly, right? So it's like the underlying mathematics, if you are clear about it, you can sort of go across the disciplines, right? So maybe that's another message that we can sort of conclude from this as well, right?
Absolutely.
Yeah.
Absolutely. That's the key, right? If you don't understand the theory, you're sort of a block-based engineer, right? All you're doing is putting a block and finding a solution. But you will never be able to solve a new problem if you don't understand the mathematics and you don't understand. And that's why the reason I went through the research I did was not to sort of overwhelm you with symbols. It's to make you understand that this is how you approach a problem. You understand what your problem is, you mathematically model it, you mathematically understand what the different solutions are. And that's through the different algorithmic knowledge that you gather by understanding the courses, right?
Yeah, I think it's mostly like you give sort of context to the mathematics, right? That's what you are doing, right? You
exactly.
Operators that had some sort of meaning in the real world, correct?
Exactly.
And I think just on the wrapping up note, most probably it's just one student probably raising, I think, her hand. Yeah. So maybe with that, we can wrap up with your question, and maybe then Praveen can take over with the sort of the conclusion, because I think this is probably one of the longest Q&A sessions that we have had. So anyhow, I'm pretty happy that a lot of people interacted and got the most out of it, right? So yeah.
Absolutely. So please, yes, the question.
Yeah, so can you hear me?
I can hear you, Tariq.
Okay. So what I'm going to ask is something very bold, and it's not very easy to quantify. But how many papers, either conference or journal, would you say is the minimum threshold to get into a top tier university for master's or a PhD program?
Okay, so I'm going to give you an extremely subjective answer, right? Because there's no right answer to this problem. It really depends, right? And I would say if you have a journal publication in a top tier journal, your chances are very high, right? With good recommendation letters and with a good GPA combined to that, you have a very good chance of getting it, right? And it's key that journal paper, and then having publications in things like CVPR, ICASP, ICIP, because we are in the area of image signal processing. To all the other folks, These are not the only best journals. There are tons of other journals in nano and all of those different aspects. I'm talking about what I know, right? If you have a couple of conference papers, if you have a journal paper, your chances are very high. Local conferences, always good to have. The other thing, Tarika, is ICIIS is something you guys organize there, right? And the professors there organize.
Yeah.
You're right, publish in those. Because having one publication, I'll tell you something very strange. I've been a reviewer for a lot of, not a lot, a few of the top tier journals I've reviewed papers for. One of the first things we do is we sort of, to understand the context of the research, we search other research done by that group or that organization. Having other example research published in other places that have already been cited is also important. So perhaps not shooting directly for the highest one, going publish in one of the conferences locally, get that work out there, right? Get your name out there, build a Google Scholar profile, then build upon that, do the next step. And one of the things we also do when I did research, personally, is you go through a research problem from 0 to N, right? And in those different steps, right, you sort of have a curve that goes like that, right? And when you are in this stage, you publish, since you want to have some publications, you go for easier publications, right? The things that you can get published easier in. That doesn't mean, some crappy, nobody knows one. Things that are good, but your barrier of entry are not as high as ICASP or ICIP. You publish in this stage. And when your research matures, that's when you go to the next stage. But the bottom line is maximize your publications as much as possible. There's no right amount. The right answer is infinity, but having the most, right? The better than everybody else. And we don't know how much that is. So as much as possible, but at least having one recognized journal or recognized conference paper would really, really put you up there. An ICASP paper on a graduate student application goes a long way, or a CVPR paper, great. If you have a journal paper, amazing, right? That's a very rare thing. Now, not so rare, I'm learning, but now it almost feels like a journal paper is necessary, even if it's not a very top tier conference paper. So, it would be best if you shoot for what I'm talking about, right? Just at different points in that curve, publish where you can, right? It's just like why I got my master's, because at that point, if things didn't work out, I need to find a job. So I got a master's along the way. And that's what you do, right? You maximize the probability for yourself with what you have. You can't magically come up with a publication that's worthy of CVPR, right? You work yourself up there, but along the way, publish. Getting rejected is a learning experience, right? And getting rejected doesn't mean necessarily that your research is bad. And getting rejected also opens up your eyes to what else is out there. I'll just to share something my professor did to me. At the very beginning of my research, he told me to put a conference paper to a very different area of research. I'm not going to mention the journal, but put it there. And when I got the results back, it was a reject, and I got like a ton of reasons why. He told me that's why I wanted you to apply there. I wanted to see what other people are doing in this area, especially because there's no research out there. And then we went through the comments, and then we understood, oh yeah, these guys are talking some other nonsense. It's not about what we did. But it's helpful to us, because it helped us understand where we are, what we are doing wrong. Are we doing anything wrong? And is there something not within here that's been done here? So, that's one aspect. But more importantly, the idea is publish along the way and get your work to a point where it can be published, and that's where your professors will come into play, because having a professor's name in there gets your chances of publication higher. Because as much as we'd like to call ourselves objective human beings, we are not objective human beings, right? So if we see somebody's name tied, we look at the names that are in that publication, and we try to look at their research, and then we go to one of their professors' profiles and we see, okay, this guy has X amount of publications and X H index, citation count. We're like, okay, our mind works that way, right? We say this might be good stuff. So, that's why it's important to work with the right people, do the right research, but publishing as much as humanly possible, but don't just publish. Don't just put in some random place. Just let me rephrase that. Maximize good publications. The journal is important. for sure. But again, where you it doesn't matter where you publish, make sure you publish properly. And another important thing is when you submit a paper, just because it's not a top tier conference paper, do not submit a bad paper, right? Because that will get rejected. Because the people who are reviewing are very particular, because people who review for free, right? If you submit an unstructured paper, reviewers take it as a personal insult, because you're wasting their valuable time for a half-baked idea. So only publish good research, do it properly, and make sure that grammar is right, structure is right. All of these are very important things, right? And my first conference paper, I went through 137 revisions with my professor. That's how many times you have to work before you put that time into it. It's worth it. So that's my advice to you. Good papers are not just subject matter. It's about structuring ideas properly. And read good publications to understand how to structure papers. Get people's advice. Yeah. So I guess it's perhaps time for conclusion. So before.
Yeah, I think so as well. I mean, like it depends on whether you actually have time, but I think it's a good place to wrap up probably, right?
Okay.
Is there any questions in the chat?
I do not see anything. So let me.
Then probably, because otherwise.
Let me conclude then, right? On my end.
Yeah, 2 hours and 40 minutes, right? So maybe you can conclude. Yeah, you can conclude. And once you conclude, you can hand over to Praveen for his conclusion, right? So clearly, from my side, I want to personally thank you for really not just the presentation, but the highly interactive Q&A session. And I think a lot of people gained a lot out of it, and you highlighted many aspects. And also, as you said, quality as well as time well spent on research, as you concluded, is very good, right? So thanks again, Dilshan, and hopefully we'll work together again on university activities as you have done in the past as well. Okay.
So thank you, and thank you to. So I want to say big thank you to everybody who organized this talk. I think this is really remarkable that you guys are doing this kind of stuff, and people like myself love to help out where we can. Right? Because as I said before, we've made mistakes, we've done things right. And that's how we want to train the generation of tomorrow so that you could do better than we did. And an important part that when you guys make that next step and you succeed in what you do, and you go to graduate school, wherever, do your PhDs, do your masters, get to a place, make sure to do as much as you can to give back, right? Because this is part of the responsibility that comes to us, right? I personally am not a student of Peradeniya, but I have a personal responsibility towards the country where I come from, right? My home, where my brother went to school, my mother went to school, my father went to university, all went there. And this is an important aspect, in my opinion, that giving back through knowledge is something we all can do. And I really encourage you guys to do that when you get the opportunity, and when you go to higher places than I am in right now, which I'm sure you guys will all do. And, and again, thank you, everyone. It was an absolute privilege. And thank you for being very interactive. I really like having conversations, and I really like to devote time to people who want to get the most out of it. So always feel free to reach out to me on LinkedIn. I'm typically a very available person, unless somebody is like killing me with work. I try to get back to people soon, because all I can do is give advice, and I'll be happy to do that. So, I'm not the only one. You have plenty of people who went from Peradeniya and who are at very good places that can help you through these things. Talk to those people, ask them questions, and, make the most of what you can. And again, best of luck to all of you. And again, to the committee, to you guys, thank you for being very professional in organizing this talk, getting things together, working with me diligently and, very timely manner. Appreciate that. And back to the audience, thank you very much for your attention. So off to the organizer.